All right, this is Professor Belton. This is part 4 of chapter 3, section 7. So now we'll get into one-to-one in the horizontal line test. We'll take a very simple function of f of x equals x squared, right? So if I do an xy table for the y equals x squared, right? x, y, -2, -1, 0, 1, and 2. So if I square that, I get it 4, 1, 0, 1, and 4, right? So basically I'm plugging these x values into there. So at -2, I'm at 1, 2, 3, 4. I'm at 1, 0, 1, and I'm at 4. Okay. So asking ourselves two different questions. Okay. Is it one-to-one and does it pass the vertical line test? So let's just change colors here really quick. So first off, is it one-to-one? That's a good question. Well, the problem is 4 in the output, right, the range, maps to two different numbers. So it is not 1-to-1. Okay. And then if you do a vertical line test, right, any vertical line you draw can only intercept the graph once. This clearly intersects the graph twice, right? Well, you ask yourself, well, I can draw a horizontal line here, right? That only intersects the graph once, correct? Yeah, but it's any horizontal line, not a specific horizontal line. No matter which one you draw, it should work, right? So if I can find one horizontal line and it fails the horizontal line check. So let's look at that algebraically, right? So the original is y equals x squared. So if I switch the variables, I get x equals y squared. Okay, so if I'm going to solve for this, I get the square root of x equals the square root of y squared. But this is plus or minus, so I get plus or minus root x equals y, right? That is not a function. That's two different equations, right? Which is not one function. Because if I graph this, right, x and y, okay, well, it's a square root, so let's pick something easy. The things that are easy for square roots are 0, 1, 4, and 9, correct? So if I plug in 0, I get plus or minus 0. If I plug in 1, I get plus or minus 1. If I plug in 4, I get plus or minus 2. If I plug in 9, I get plus or minus 3. Because again, this is y equals plus or minus the square root of 9, right? So 0, I'm at 0. Let's do a different color here. Let's do that one right there, right? So 0, I'm at 0. At 1, I'm at 1 and -1. At 4, 1, 2, 3, 4, I'm at 2 and -2. And the 9 is going to be off the graph, right? So clearly, if this is my inverse, it is not a function, right? Not a function. It fails the vertical line test, right? So a horizontal line test basically proves that the inverse will not pass the vertical line test, right? Okay, let's go back to blue and look at the following graphs. So do the following have inverse functions, right? So does it pass the horizontal line test? Yes. Has an inverse function. This one does not pass. That's not really horizontal. Let's try that a little better, right? No inverse function. Okay, does this one pass? Well, it passes sometimes, maybe, but again, you get extended forever, so it doesn't pass there. And it really doesn't pass this either if you extend it. So no inverse function. Okay, and then lastly, does this one pass? Yeah, sure. No matter where you draw your horizontal line, it has an inverse function. Okay, so essentially, A and D pass the horizontal line test, and they are one-to-one. right? And the question is why? So why did B and C fail? Well, one, they failed the horizontal line test, and two, when you draw a horizontal line, right, it's also not 1-to-1. So my range here, so my range is y, right? So these have a certain y value, whatever the y value happens to be. So that's some kind of y value. That's some kind of y value, right? But this is a positive x value here, and this is a negative x value here. So it is not 1-to-1, right? Because for every y value, I'm getting two different x values. It's not 1-to-1 there. No inverse function exists. All right, pause the video, try the student problems. Okay. All right, so for the student problems, I'll have you write it. Whoops, let's turn the pen on there. Try that again. So it fails the horizontal line test and is not 1-to-1, right? So no inverse function. Okay. This has an inverse function, so has an inverse function. And is 1-to-1. And this one, no matter what you do, has an inverse function. It passes the horizontal line test and is 1-to-1. Okay, so in the cases where it has no inverse function and doesn't pass the horizontal line test, you'll have to do domain restrictions to be able to make inverse functions, which is what you'll do in trigonometry and in the coming sections.